Voltage drop is a decrease in voltage that occurs along a conductor in an electrical circuit. It is an important consideration in electrical design because excessive voltage drop can cause equipment to malfunction or operate inefficiently. Different types of equipment have different sensitivities to voltage variations. Sensitive equipment, such as electronic devices and computers, may require a tighter voltage drop limit to function properly. Non-sensitive equipment, such as lighting and motors, can typically tolerate high voltage drop. The National Electrical Code, or NEC, provides guidance on voltage drop in section 210.19. The NEC recommends that the voltage drop on branch circuits should not exceed 3% and the voltage drop on feeders should not exceed 5%. The total voltage drop on both feeders and branch circuits should not exceed 5%. These are recommendations, not mandatory requirements, but they are widely followed in the electrical industry. For non-sensitive equipment, a voltage drop of around 5% is generally considered acceptable. This means that the voltage at the equipment terminals can be 5% lower than the voltage at the source. For example, if the source voltage is 120 volts, the voltage at the equipment terminals can be as low as 114 volts. Non-sensitive equipment is less likely to be affected by voltage fluctuations because it is designed to operate within a wider voltage range. Lighting, for instance, might dim slightly but will continue to function. Motors might experience a slight reduction in speed and torque, but in most cases, it will not be significant enough to cause problems. However, it is still important to minimize voltage drop as much as possible, even for non-sensitive equipment. Excessive voltage drop can lead to increased energy consumption, reduced equipment life, and potential safety hazards. Several factors can contribute to voltage drop, including the length of the conductor, the size of the conductor, and the amount of current flowing through the conductor. Longer conductors will have a higher voltage drop than shorter conductors. Smaller conductors will have a higher voltage drop than larger conductors. Higher current will result in a higher voltage drop than lower current. To minimize voltage drop, it is important to select the appropriate conductor size for the application. The NEC provides tables that can be used to determine the minimum conductor size required for a given current and voltage drop. It is also important to keep conductor runs as short as possible and to avoid excessive current draw. There are several ways to calculate voltage drop. One common formula is voltage drop equals current times resistance, or volts drop equals amps times ohms. The resistance of a conductor can be calculated using the formula resistance equals resistivity times length divided by area, or ohms equals resistivity times length divided by area. Resistivity is a property of the conductor material and is typically expressed in ohms per circular millifoot. Length is the length of the conductor in feet. Area is the cross-sectional area of the conductor in circular mils. Another method for calculating voltage drop is to use voltage drop calculators that are readily available online or in electrical engineering software. These calculators typically require the user to input the conductor size, conductor length, current, and voltage. The calculator will then calculate the voltage drop. It is important to note that voltage drop calculations are only estimates. The actual voltage drop in a circuit may vary depending on several factors, including the actual load in the circuit, the temperature of the conductor, and the presence of any splices or connections. Therefore, it is always a good idea to measure the voltage drop in a circuit after it has been installed to ensure that it is within acceptable limits. If the voltage drop is too high, there are several things that can be done to reduce it. Firstly, increase the conductor size. Using a larger conductor will reduce the resistance of the conductor, which will reduce the voltage drop. Secondly, shorten the conductor length. Reducing the length of the conductor will reduce the resistance of the conductor, which will reduce the voltage drop. Thirdly, reduce the current. Reducing the amount of current flowing through the conductor will reduce the voltage drop. Fourthly, improve connections. Ensure that all splices and connections are clean and tight to minimize resistance. Finally, consider using a voltage booster. A voltage booster is a device that can be used to increase the voltage at the equipment terminals. This can be a useful solution if it is not possible to reduce the voltage drop by other means. When designing electrical systems, it is important to consider the voltage drop requirements of all equipment connected to the system. Sensitive equipment may require a tighter voltage drop limit than non-sensitive equipment. The NEC provides guidance on voltage drop in section 210.19, but it is important to consult with a qualified electrical engineer to ensure that the voltage drop in a system is within acceptable limit. In summary, voltage drop is a critical factor in electrical system design. The NEC recommends limiting voltage drop to 3% on branch circuits and 5% on feeders, with a total of 5%. Non-sensitive equipment typically tolerates around 5% voltage drop. Minimizing voltage drop ensures efficient operation, extends equipment life, and enhances safety. Factors influencing voltage drop include conductor length, size, and current. Use appropriate conductor sizes and keep run short. Calculate voltage drop using formulas or calculators. If voltage drop is excessive, increase conductor size, shorten length, reduce current, improve connections, or consider a voltage booster. Always consult a qualified electrical engineer for complex designs.